Let's do this. So we're going to talked about fractions. We've talked about reducing. We talked about factoring, stuff like that. Let's talk a little bit more about factors, fractions, ratios, percents, decimals, things like that. So we start with something simple, 3/4. So right away, let's look at what our numerator is. Our numerator is equal to 3. Our denominator is going to be equal to 4. This says divided by. Divided by. That's what it says. So it says 3 divided by 4. We read it top to bottom. So we have the anatomy of the fraction is the numerator and the denominator and the divided sign, right? The parts of it. But we could also look at it as numerator equals the part and the denominator equals the whole. Okay? Or we could say the base amount. How is a fraction, a percent, a ratio, a decimal? How are those things related? Well, they're all the same thing. So let's talk about that. So how are they the same thing? Well, we just said that 3/4, or 3/4, is the same as 3 divided by 4. So if we carry that out in longhand, it looks like this, right? So we say, can 4 go into 3? And we say, well, no, it can't, because 4 is bigger than 3. So we say 4 is greater than 3. Now, if 4 were less than or equal to 3, then it would work. But that's not a true statement. So we're going to get that off the whiteboard because I don't want to freak you out. So we could say that 3 is less than or equal to 4. So we would say that would have went into 4, no problem. But that's not the case either. So we're going to get that off the whiteboard. So 4 is greater than 3, so we mean to say it can't go into 3. But because it's a 10-base system, right, because we have the 10th spot, the 100th spot, the 1,000th spot, 10,000ths, 100,000ths, millions, 10 millions, 100 millions, billions, so on and so forth, right? And then we have the units, or ones, tens, A to Z, that's how it works. That's a 10-base system. So I'm going to clear this out really quick. A to Z, A to Z, that's how it works, right? So does 4 go into 3? No, it doesn't. So we draw a decimal and a 0. So 4 goes into 30. Sure, well, I understand that that's not a 30, but because it's a 10-base decimal system, we can just move the decimal one place and it will be just fine, right? Because if I said 4, let's just say 4 times 3 is equal to 12, right? But if I move, and that's the same as 4 times 3.0, right? So if I move that decimal place one place over, it'd be, whoops. If I move that decimal place one place over, like that, it'd be 4 times 30. So we'd have 4 times 30, and that equals 120, which this was 12.0. So now we just go one place over, right? So that's all we're doing here. So we're using that as an algorithm, or a series of movements, or a series of actions that we can take to get a certain result. So, and it's just one that's been tested and is proven, that there's a mathematical proof for it. So we use that because it's always going to work. We don't like anomalies in math whenever we can avoid them, right? So we have 4 goes into 30 how many times? Well, 4 times 7 is 28. So that's the same as saying 4 7 times, right? So I had 1 2 3 4, 1 2 3 4, and I did that 7 times, I would have 28. So 7 times 4 is our next step. We go ahead and do that just to show what we got, and we got 28. So we subtract this imaginary 30 by 28. When we say, well, what's the difference here? It is 2. And 4 cannot go into 2. We're going to do the same thing. And so we draw a 0 and drop it. 4 can go into 20. 5 times 4 is 20. And that zeroes out. So the reason that this little algorithm works is not because it's magic or anything like that, or any mystery to it. It's just that we're understanding how a decimal system works, and we're just moving the decimal over kind of figuratively in our mind so we can carry out this math. Because if we would have said 4 into 300, we would see that it goes 75 times. Which brings us to our next point. It's out of 100 means per, right? 100. What's another way to say 100? Well, if you live in the United States, we know that 1 out of 100 is a cent, because 1 penny is 1 out of 100 pennies is a cent, 1 cent of a dollar, right? Because a dollar is a cent, a century, 100 pennies, right? So per cent means per 100. So another way to write that is percent, or percent, right? So we see that we have 75%. Right here it's written in the form of a decimal. So we see 0.75 is equal to 75%, but we don't see a decimal in here because 75% is the same as 75.0%. So all we did was move the decimal 1, 2 over. 0.75 means that we have 75 out of 100, which is 75 per 100%. Cent is again another way to say 100, right? So we have 75 per 100, 75%, and that is 0.75 of a whole, right? Because our 100 in this case is one whole, right? Again, just moving that decimal around because we're getting to a whole pi. We always use a pi because it's a nice easy thing to use. So we said if we had 3/4, that's what we started with for all this, right? If we had 3/4, that means we have 4 total in the base, right? And we have 3 parts of those 4 totals. It was cut into 4 slices and we have 3 of them, right? So another way we could write that is we could draw that same pie and we could slice it into 100 pieces. And if we slice it into 100 even pieces, which you can feel free to do on your time, and we color in 75 of them, it will look exactly the same. We'll see that we have the same amount of pi as we had here. These are equal, right? Alright, so that's the relationship between percent and decimal and fraction. So we've seen how we got to a decimal. We took 3/4 and we just followed what it says, 3 divided by 4. And the way we did that was 3 divided by 4, right? And we got 0.75. Alright, we'll put that there just so you can understand what's going on, right? Then we move the decimal 1, 2 places to the right, and we make it a percent. No matter what the decimal is, we only move it 2 places to the right, right? Because that's the 100th place, and we get our percent, 100, right? Now, we understand how all that works. So a ratio, what's a ratio? Well, when we have a whole, in this case 4, and we have 3 of 4, we have 3 per 4. Okay? 3 to 4 ratio. It means we maintain a ratio. And now we can increase that by a factor. And we talked about what a factor is. A factor is a number that is multiplied by another number, so therefore that other number is also a factor. And the answer that we get is called a product. So if we increase this ratio as a whole by a factor of, let's say, 2, we have to multiply each by 2. So we'll see that if we do that, that becomes a 6:8 ratio, which is the same thing, just how we demonstrated how 3/4 of a pi is going to look the same as 75 100ths of a pi. Okay, same here. We've just increased it by a factor. What we did to one side, we did to the other. And get used to hearing that because that's going to be really important when we get into algebra. We're going to have to keep our equations true statements. And by that I mean an equal sign will be written. And we'll just touch on that real quick. Just really, this is some of that stratification that I talked to you guys about. So if I said 3, we're going to keep it simple though. 3 plus a is equal to, let's say 5. So nice and easy. We know that a equals 2, right? But we can use algebraic methods, which again, it's just a method. It's an approach to it. There's more than one way to solve for a, but algebra provides us with a nice, easy little tool. So we can say, let's get this variable term. This is a variable, and we've talked about the definition of variable. Variable means it's some unknown value, right? And we have a constant term. That's a known value. That's a 3. And here's a constant term. So we're going to try and get that variable all by itself. And so in truth, what this really says is positive 3, positive a equals a sum of positive 5. So we're going to get that positive a by itself. Well, how do we get that positive 3 to 0 on this side? Well, we subtract 3, and that will cancel it out. Now, we said whatever you do to one side, you have to do to the other, because this is an equal sign. It says equals. So if the first bit of the statement was true, if the first way it was written was true, 3 plus a equals 5, and I get rid of this 3, well then this can no longer be true. Therefore this equal sign is dishonest. And we want to keep that equal sign honest, so whatever we did over here, we have to balance it and do the same thing over here. Just imagine it like a scale, right, or a teeter-totter. Whatever we take away from one side, in order to keep it balanced, we're going to have to take away an equal proportion from the other side. So we're going to come over here and we're going to subtract 3. So A is equal to 5 take away 3. So 5 minus 3 is going to equal 2, which equals A. So we see that whatever we do to one side, we have to do to the other. All right, cheers.